So now in this video, we're going to look at a circuit fragment I just learned about, and so I took the circuit fragment from a book called The Art of Electronics. In one of their circuits, it's wired quite a bit differently. This is my demonstration circuit version, but I just got that from the book. I just learned about this circuit, so hopefully after a little more experience I'll be able to make a good web page and whatnot, a diagram on this, but for now I'm just going to do a quick demonstration circuit. So we have a transistor here, NPN bipolar junction transistor, a 10 volt power supply. It's set to 10 volts, and that's the current that it's outputting approximately. This is not the most accurate current meter, but if I complete the circuit by connecting the emitter directly to ground, now you can see there's about 10 milliamps of current going through there. So this is basically wired as a switch, really, that is always on for the most part, a transistor switch. So a small base current going from base to emitter that allows full as the transistor, which is pretty much fully, will allow full current to go through that resistor, the transistor, into ground. So that is a 1 kilo ohm resistor. This is a 10 kilo ohm resistor going to the base. And so the 1 kilo ohm resistor, as you can see, we got about 10 milliamps. This is 1 amp, a hundredth of an amp, or a tenth of an amp, I mean, a hundredth of an amp, and a thousandth of an amp. So this is 10 thousandths, which is the same as 10 milliamps. And that's about what's going through there. But we also have the current going through there, which is going to be about 1 milliamp. And so we can look at that with the meter. So I'll plug this because it's more accurate. So the math will line up, as we'll see here. And grab the probe. Make sure you can see that. There we go. And we'll complete the circuit there. You can see it's a little shy of 11 milliamps right there. If I move this resistor up, because we have the two currents coming together, now you can see it's about 0.94, so about 0.9 milliamps. That was one of the currents going there. We were measuring two currents put together, so we added up the current going through this resistor. There's also a diode drop there, but mostly it's the value of the resistance setting the current going through there. And now I'll go up to the collector, and we had just shy of 10 milliamps going through this resistor and then collector to emitter down to ground, but a total of about 11. So in any case, that's basic transistor switch stuff, and so I'm not going to look at that anymore. Now we are going to zoom in and show the modification. So first, let's just do a quick. We're going to take a 100 ohm resistor. So this is going to the emitter and then just down one row. And that will be nice placement for our next transistor. We need a second transistor to set the current. And there you can see it's just down one row. And this by itself will start limiting current a bit more because it has resistance right there. But that's not the main thing about this video. So you can see we have the two current paths. Now we have that extra resistance of about 100 ohms right there. So it lowered it a little bit. Now we're going to take the other transistor, and this is where it really gets interesting. So let me see if how much I can zoom in. So the collector, so these are NPN bipolar junction transistors, the 2N22. We got the emitter on the left, base in the middle, collector to the right when the flat side is looking at us. So we're going to put the collector towards the top. That's going to go to this jumper, which goes to the middle pin, the base of that transistor. And then the base is going to the emitter there, and then the emitter is going to the resistor right there. So what you'll see here is that the base is to one end of the resistor, the emitter to the other. And so when a voltage builds up across this resistor, then it will build up across here. Once it gets to about 0.6 or 0.7 volts, based on how much current is going through it, then this transistor will start conducting. And so I'm just going to quickly show the jumper for a visual. You can see here that the rest of the circuit will be going to ground right there. and now you can see we got some current flow right there. But in any case, we got that. So you'll notice there that if this transistor is conducting, then we have a path from the collector there through the transistor when it's conducting to ground. So the collector up here goes to the base of this one. If you lower the voltage to the base there, especially if you connect it directly to ground, that turns it off. And so as long as there's a voltage build up there, it's going to give the base of this transistor, which is allowing the current to flow through there, to basically shut down. Ultimately, it limits the current to whatever that resistor, the voltage across it, is. Once current is flowing through it, it'll build up a voltage across it and start turning this one on, connecting the base of that one to ground. And so ultimately it's going to hold right at the voltage where that transistor starts turning on. It's going to let the current flow through to do that. So let's zoom back and actually look at that. So the main thing to take away is right now we have a 100 ohm resistor. You can see that says 6 milliamps, but as we already saw, it's not as accurate as the multimeter. I wish it was, but unfortunately it isn't. Plus, you should know how to use the multimeter, not just trust the current going on there all the time. So right there, that's 7.15, and there you go, 7.15. So if we cut this in half, we'll have about 3.5 volts approximately, maybe a little bit more. That's if we cut it in half. We're going to pluck out the 100 ohm resistor and grab a 220 ohm resistor. So that's a little more than half, but 3.5 volts is a little less than half of 7.15. So we're probably going to be really close to 3.5 volts. Right there, you can see it's close. And main takeaway is the more resistance here, the more voltage buildup we will have. So let's look at that. Let's take the jumper here and complete the circuit. So now current's flowing through. The power supply says about 0.003 amps, which is 3 milliamps. And so we're going to not measure current now with this. We're going to measure voltage right there. So we're going to measure the voltage at the emitter of the transistor, and I can zoom in, no point being that far away. So we're going to go to the emitter of this transistor and then the base, the middle pin. Being very careful because there's a lot of stuff there. There you can see that is the voltage that you need to get the base to emitter to start conducting, and ultimately that means the collector starts connecting to the emitter and pulling the voltage down. The collector is to the base of that transistor, so it will make it so it doesn't conduct as well, ultimately limiting to the current to whatever it takes to build up the voltage across that resistor. So that's a 220 ohm resistor, and we can see at about a little more than 3.5 milliamps, it built up a voltage of about 6.3 or 0.63 volts, something like that, enough to get that transistor to start conducting. So again, this is not intended to be, I kind of expect you to know about transistors by now if you're watching this video, but in any case, whether you do or not, hopefully you still find it interesting. So now we went back to the 100 ohm resistor, and you can see the power supply is kicking out probably 7 milliamps of current, but that says 6. It's close enough. You can see it went up. But in any case, that's a 100 ohm resistor, and we can look, if I go to the base again, there's that same voltage right there. But we will have more current because it's a lower resistance. So it's going to take more current to go through that resistor to raise its voltage to 0.62 volts. And there you can see now we're back to the 7.13 milliamps current. So that's the maximum. We could have more circuitry down here that needs less current. It has more resistance, so it'll limit current. That will be just fine. But if it starts, like we have a short circuit. I've been doing a short circuit with this jumper, but if you have a short circuit somewhere, then it's going to stop at that maximum current through that whole thing, and you can use it as a protection. In fact, that's why they mentioned it in the book, The Art of Electronics. It was part of a much bigger circuit, more complicated than this, and I had to read the notes, why they had that particular circuitry there. And that second transistor, you know, basically piggybacking on that one, plus a voltage setting resistor down there. When I read the text, I saw that was to limit a maximum current for mostly short circuit protection. But you could limit it for other reasons too, if you get creative enough or whatever. So, in any case, hopefully I can make a more interesting video on this circuit. I find this one really cool, so I'm sure I will in not too long. So thanks for watching. I will see you in the next video.